So this is the maximum height projectile problem. Sarah is throwing a rock with an initial velocity of 20 meters per second. That velocity is 30 degrees up from the horizontal. The question is, how high does that rock go? I'm going to take this statement and I'm going to pull out all of my given and implied variables here. I know I can calculate my initial velocity in the y direction because I'm given the total initial velocity and the angle. And so I know my VIY is going to be 10 meters per second. And that's because this is just a right angle triangle. The sine of 30 is 1/2, so 1/2 times 20 is 10 meters per second. So I know my VIY. The tricky part in this maximum height problem is knowing that as the object gets to the top, basically the final velocity is 0 meters per second, and so that's implied. Acceleration, I'm assuming this is on Earth. Acceleration in the y direction is negative 9.8 meters per second squared. The delta d is the thing that we are interested in, and so these are the 4 variables that I'm going to use when I go to choose my equation. Delta t doesn't even enter into it, so I don't have to care about that at all. Good. Here is the equation, and I'm not sure which one it is. It might be equation 2, but the final velocity in the y direction squared is equal to the initial velocity in the y direction squared plus 2 times the acceleration times the change in displacement in the y direction. And this is 0, and the initial velocity we worked out is 10. We're going to be squaring that. My acceleration, and I'm going to have to isolate my dy. So I'm going to move my 10 squared, or my 100, over to this side. I'm going to be dividing by 2 times negative 9.8, which is negative 19.6. And that is going to tell me my change in y direction when this object ultimately gets to the top of its flight and the y direction velocity is turned to 0. And this is equal to 5.1 meters.